Alrighty, we're going to talk about concavity here, and also review increasing and decreasing and critical numbers and relative extrema as we talk about concavity. Now, let's put some key points on this graph right here. Some key points we want to look for is this right here. That point right there is a really kind of important one. There's something special happening there. This point right here is a really special one. We'll talk about that one. This one right here helps you graph it, but not so special. That's just an x-intercept. So that one's not. And there's a point right here that's extremely important for this section. Those are some really, really important spots that we're going to be poking on. So this right here, this one, and this one are three very important spots. You want to highlight those and point those out. We're talking about concavity. But before we get to it, actually, let's just talk about what we know about increasing and decreasing. So we're going to look at the graph and see what intervals it is increasing, meaning it's going up. If this was a roller coaster, woo, and whoa, that's going to not have enough speed to go up that. But you can see increasing means going upward, or the slope's positive. So hopefully you notice it is increasing from this blue dot forever up, for what we can see. Assuming there's nothing that's going to happen more over here or over here, assuming it keeps going up on both sides. But so our interval for which it's going increasing is going to be from 3 forever up. So let's call that from 3 to infinity. Now, you might wonder why I put a bracket, because how they write increasing is closed interval. It's just the way it's written. You could also write this as x is going to be greater than or equal to 3. Either way works. So, what is decreasing? Well, you could guess it's everywhere else. But you could also say your roller coaster is going down all the way until there. Yes, it's flat right there at 0. But if I wrote an interval here and an interval here with greater than or equal to's, wouldn't they overlap, make it downward the whole way? So what we're going to call that is, we're going to say from negative infinity to 3, it is going downward, decreasing, which is x values less than or equal to 3. Even though it is 0 at this point, we're just going to include the whole thing instead of breaking into 2 intervals of decreasing. All right. Now, again, I'm not going to come to concavity quite yet. Let's go to these 2 pieces, which is review. Critical numbers. Critical numbers are where your derivative equals 0 or undefined. So let's look, where is our slope or our roller coaster flattening out? So I can see right there, it gets a slope of 0, flattens out, and right here. So I have 2 spots are critical numbers. So my critical numbers are at x equals 0 and 3. That's a critical number. It's a spot where there's something critically happening, where slope is 0 or undefined. There are no slopes being undefined on this graph, just 0. All right. So relative extrema, don't they have been at these? Possibly at these. These are the 2 spots you could have a relative extrema. So let's look at 0. Is that a relative extrema? Is that a relative max or min? No, that's just a level off. So it's nothing. That's just a critical number for now. Okay, but at 3, does something happen? Yes, that is a valley. So that valley is called a relative min. So I'm going to call that a relative min. I'm abbreviating it. The coordinate is 3, and how far down is that? Looks like 3, negative 3. So far, we have critical numbers, extremas, increasing, decreasing, all previous topics. Now we're going to get into concavity. So let's talk about the concave up and concave down. Concave up and concave down look like a cup or a smile. So if I say something's concave up, it looks like that. Kind of like a U for up. If you kind of notice that. Concave down, looks like that. Upside down. So graphs have this look. When I say increasing, it looks like that. When I say decreasing, it looks like that. It could be in the other direction as well. But so concavity is more of a curvature. I call this a smile and a frown. So where do we have a smile look? Well, we kind of look. Okay, let's look at these key blue points are going to be kind of important. So at this point, right here, do you kind of see, is that a smile or a frown? Can you see that's a half of a smile? And then from here to this blue dot, does that look like a frown? And then from here to this blue dot and beyond, does that look kind of like a smile again? So did that dot change any concavity? No, that one didn't. But from here, there, does that look like a smile? For this little part, that's like half of a frown, and right here looks like half of a smile. Okay, so what we got to do is we got to put the intervals of up. So where I see up is I see it right here. So I see up right there, and I see up right there. Oops, I forgot right here. Do you see how those two spots are going upward? So I'll call those intervals from negative infinity to 0. Now this is open interval on this one. Increasing, decreasing is closed interval. It's kind of weird. And then I also have from, 2 to infinity. That is where we're up. You could also call that less than 0 and x is greater than 2. So that's another way of putting it. Now concave down, hopefully you can see, is this piece right there. This piece, if you didn't see the blue there, is right there. Is concave down. It looks like a frown piece. And so that would be interval from 0 to 2. Or you can write that as, let's see, but x is between 0 and 2. Either way works. So now we have the intervals for concave up, concave down. We can kind of see it from the graph. Last point is something called a point of inflection. A point of inflection is the points at which you change your concavity. I call it your mood change because it changes from a smile to a frown. Do you notice there are 2 mood changes? Do you see 2 spots? Do you see right here and right here? Do you see both those spots are spots where it's changing concavity, where the concavity breaks at 0 and 2? Do you see those 2 spots? So my points of inflections are those places where it changes. So what I have here is my first coordinate would be 0 is a coordinate, and that's 0, 0 is your first point of inflection. That's this one. And this one right here is your other point of inflection, which is 2, we got a negative 1.75 maybe from the graph about. We don't have it exact. We'll call it 2, negative 1.75. Those are points of inflections. Now, I want to point something out. It's kind of interesting. Look at this one right here. Wasn't that a critical number? When critical numbers do not come up to be extremas, it's very likely they will come up to be points of inflections. Got it? If a critical number, for some reason not extrema, has this flattening effect, is it very likely that flattening effect, it could probably be a point of inflection. That's why it didn't show up there. There's something else critical later on down the road that becomes critical. So concavity. That's what we're dealing with right here. Any questions?